Hi, my name is Courtney. In this problem, we are asked to verify that a given function f has an inverse function, and then to use the function f and the given function value f of x equals a in order to find what f inverse prime would equal at a. We're given the particular function f of x equals x cubed minus 1, and the evaluation that at x equals 3, f of 3 is 26. So let's start with the first part of this problem. We need to verify that our function f of x equals x cubed minus 1 has an inverse function. Well, what do we know about f of x equals x cubed minus 1? In particular, we know that its parent function is f of x equals x cubed, and that f of x equals x cubed minus 1 is just going to be a vertical translation down 1 unit from that parent function. Since we know the parent function, x cubed, which we might think of as g of x equals x cubed, is 1 to 1, we know that shifting that graph down 1 unit, we will still have a 1 to 1 function. So f of x equals x cubed minus 1 is also 1 to 1. Now that we know that our function is 1 to 1, we can say for sure then that f of x has an inverse. So it makes sense then to continue the problem, which is going to ask us to evaluate the derivative of that inverse function at a particular value a. So how do we do that? Well, let's first notice what our value a is. What we have with this information, if we look at the information provided, is an x value of 3, corresponding to our f of x, and an a value of 26. Again, just going back to the form that f of x equals a, where we were given that f of 3 equals 26. And so what we've been asked to find is what is f inverse prime? In other words, what is the value of the derivative of f inverse at the value a? So at 26. This is the value we're looking for. And what we've seen is that the really powerful thing that we can do with the tools that we've learned through this section is that we can evaluate the derivative of the inverse function without ever having to actually go find what that inverse function is. In particular, we know that inverse functions have reciprocal slopes, and the derivative is just telling us the slope of the function. So the derivative of the inverse function will be the reciprocal of the slope of the original function. So f prime is telling me the slope of my original function. But remember that we also change inputs and outputs when we move from a function to its inverse. And so instead of evaluating f prime at 26, I want to go back and I want to evaluate it at 3, the corresponding input. So all I need to do in order to find the value of f inverse's derivative at 26 is to evaluate the derivative of f at 3 and then take its reciprocal. So this is the part that we have left. We know f of x is x cubed minus 1, and so its derivative, f prime of x, will simply be 3x squared. And if we evaluate this derivative, f prime, at our value of 3, f prime of 3 will be 3 times 3 squared, or 27. And then we can use this value for f prime of 3 in the relationship that we have above And we find that the value of f inverse prime at an input of 26 will equal 1/27th. Great job persevering through this problem. Now you're ready to get some more practice on inverse functions and their derivatives on your own.